La la la. La 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 la. All right, recording. Beautiful. Okay, so again, let's take a look at this example in here. So a fair coin is flipped 14 times, right? And we need to predict, we need to make a prediction about the number of times we expect to have the head to be face up, right? So we're gonna toss the coin 14 times. How many times do we expect? What is the prediction? All right. So we can do this theoretically or we can do this experimentally. Doing this experimentally means we are going to create our table. And instead of having 6 outcomes, we just have 2, heads and tails. We toss the coin 14 times and we see the results. That is the experimental part, right? But the theoretical is making a prediction without having to do the experiment. And this is simple. This is how we calculate it simply. Look at it. Look at this. We're gonna take the total amount of flipping, the total amount of times we flipped it 14 times, and we're gonna multiply it by the probability of getting heads. So the probability is 1/2, right? 0.5. That is the probability. So the solution is 14 times 0.5. We expect to have 7 heads. That is our prediction. Now, is the prediction perfect? Of course not. Nobody knows the future. Not really. Nobody. So this prediction could have mistakes. But it is a good prediction because we are using the laws of mathematics to say our results. Again, in case you don't know, you didn't know this, let me see if I find the formula here. No, there's no formula. Let me write it here then. New. Just a piece here. All right. What is the probability of an expected value here? The expected value, sorry about the letter, guys. Expected value. This is going to be the formula. You're going to multiply the total amount of times, right? So we're going to call this repetitions. So the repetitions times the probability of the event. That is the expected amount of times. The repetition times the probability of the event happening. In this case, the probability of the event happening is 0.5. That is the probability, right? That's the probability that we get a head when we toss a coin. 0.5. And the repetitions are 14. Look at this. We are going to toss the coin 14 times. So 14 times 0.5, that is the expected value. 7. We expect to have a 7. All right. Let's continue with the next question. A statistical data built up over 5 years shows that the probability of a student being absent at a school is 0.05. This is the probability, right? So the probability that you guys are absent to my class or maybe English or Spanish or whatever is 0.05, right? And in this particular school, we have 531 students. So it's not a big school, right? We have around what? Around 2,000 students in our school, right? So this school is not that big. Now let's jump into the question. Predict the number of students you expect to be absent. Look at this. We are going to make a prediction about what we expect, right? So how do we solve that? Absolutely simple. Look, according to our little formula over here, we have the repetition times the probability, right? We know the probability that a student is absent is 0.05. And the repetitions in this case are the amount of students, because this probability is for every single student, Here we have 531 students. So as you can see in question B, the solution is 531, the repetitions, times the probability, 0.05. That is expected value of 26 students. Sure, all right. 26 rounded down, but you can round up, so this will be 27. So the solution in the book is around 26 or 27 students are expected to be absent on one particular day, on just one day. A lot of students, right? So look, the probability is small. The probability that a student is absent is really, really, really small. Only 5%, 0.05. So 5%. The probability is absolutely small. It's almost not existent. 5%. But if we have 500 students, now the amount of people absent can be really big. Can be really big. 26 or 27 students. Huh? How about that? All right, this is our prediction. This is our prediction. We expect 26 or 27 students to be absent. Let's take a look at question C. This is one more of analysis, right? Look at this. State the assumptions supporting your answer in part B. Because in this, whenever we make assumptions, whenever we make predictions, whenever we expect something to happen in the future, we need to make assumptions, right? We assume some things. In this particular case, look at the answer. The assumption is that every single absence on every day are equally likely. So for example, you could be absent, I don't know, again, let me start again. The probability that the student is absent today is 0.05, but maybe the probability that the student is absent on Halloween, maybe that probability is bigger, right? I mean, I love Halloween, but I don't know about you. Maybe you guys don't. So you just don't go to school, right? So that probability could go up depending on the day. One assumption that we are doing is that it will not go up. The probability will not change. Look, this assumes that the absence on all days are equally likely. The probability doesn't change depending on the day. That is one that is one assumption that we have to make here. All right, cool, guys. But what about this example? This one is better. This one is a lot better, right? This one is a lot better. I promise you that. Wait, what happened here? Ah! No. There. Let's take a look at this question in here, guys. Let's take a look at this question. All right. This is where things get a little bit more interesting with probability, because probability is absolutely simple. But when we get to this part of questions, then are still simple but more interesting. Right. So a coastal town carries out a survey of tourists. They carried out this survey in 2018, July 2018, right? Now, the accommodation type chosen and the age of the tourists are recorded. So our survey is asking for two things. One, accommodation, and two, the age. En caso de que no sepan, accommodation significa en dónde te estás quedando, ¿sí? ¿Cómo te estás quedando? Eso es lo que significa accommodation. And here we have the information in this data. Here in this table, we have the information. So let's take a look at this. Accommodation type. We have maybe some people are staying in a hotel. Some of the people may be staying in a camper van. I have no idea what this is. Or they have a tent, or I don't know, they have an apartment, right? These are the 4 accommodation types, right? And this is the age. From 18 to 30, from 31 to 50, 51 to 70, and people bigger than 70 years old. All right. Okay. So these are the results. All right, let's take a look at this. This, for example, if I take any number at random, this 125, this means that 125 people are staying in a tent and are between 18 and 30 years old. Right? So can you guys read the full table? Did you understand the full table, guys, or not? Yes or no? Anyone? Thank you, Majo. All right, somebody said no at least. All right, thank you, Majo. De nuevo, lo voy a volver a hacer. Listo en españolito esta vez. Este poco de numeritos que hay acá son los datos que recogieron de la encuesta. ¿Ok? Entonces, madre. Mira, todos estos datos de acá son los datos que recogieron de la encuesta. Saber leerlos nos permite interpretar la encuesta o interpretar los datos. Por ejemplo, cojamos, a ver, al azar, cojamos estos 76 de acá y tratemos de entender qué significa ese 76. Ok, por la posición donde está, mira, justo arriba tengo campervan. No sé qué es un campervan. Imagino que es un carrito de esos en los que uno vive, un bus de esos en los que uno vive. La verdad es que no tengo idea. Pero estas 76 personas viven en un campervan. No solo eso, sino que también estas 76 personas tienen una edad entre 51 y 70 años. Eso es lo que dice ahí. Saber leer estos datos nos permite interpretar la cantidad de gente que tenemos. Por ejemplo, estos 87. Ok, esos 87 tienen una edad entre 51 y 70 años y se están quedando en un hotel. Hay 87 personas que se quedan en el hotel que tienen esta edad. ¿Ok, Majo, mejor? Majo.
Sí, good,
Cool, mi niña, no, con mucho gusto. All right, so let's take a look at this. In the chat, please, try to answer my question. Try to answer my question. How many people are staying in an apartment? How many people are staying in an apartment? Write it in the chat, please. You can use your calculator if you want to.
294.
Whoosh! You did it really fast, Karen. Really good. Thank you. All right. All right. So we have 1, 2, 3, 4, 5. 5 people who will least practice the exercise, right? 6 people now. So how do you know how many people are staying at an apartment? Okay, look, 32 stayed at an apartment with this age. 119 also stays at an apartment. And the difference is that they have this age. Another 89 are staying at an apartment. The last 54 here are staying at an apartment. So to know the total, all you have to do is add. And yes, the solution will be 294. Thank you, Karen. And thank you to all of the people who practice in the chat. Thank you. Thank you, guys. Thank you. All right. Let's take a look at this now. How many people are older than 70 years old? How many people are older than 70 years old? In the chat, please. In the chat. 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 Only 3 people, guys. Come on. You can do it. Come on. People that are older than 70 years old. How many do we have here? All right, we have 1, 2, 3, 4, 5, 6, 7, 8, and 9 people practicing. Guys, you are not gonna learn if you just wait for me to give you the answer, right? You are not gonna learn if you just wait for me to give you the answer. You have to practice. Congratulations to all of you who did practice, because all of you are correct. Majo was wrong, but you corrected it. Congratulations, Majo. All you have to do is add all of these. These are the people who are older than 70 years old. So 109 plus 32 plus 15 plus 54, 210. Congratulations. Congratulations. But what if I say, how many people are younger than 50 years old? Let's see how many of you do this correctly. How many people are younger than 50 years old? Younger than 50 years old. Let's see. In the chat, please. In the chat. I'm doing it as well. Uh-huh. All right, how many? Wow. Look at that. You guys are actually paying attention. All right. Cool. Nobody else, guys? Come on, nobody else? All right, congratulations to the what? 9 people who practice in the chat. You guys are correct. 834. Now, some of you might say, but teacher, this is not 800. Come on. This is not 834. Sure, it is not. But I did not ask for the people who are between 31 and 50 years old. I did not ask for that. I asked for the people who are younger. So I'm counting all of these. 18 to 50. Huh? You needed to add all of these 4. All of these 8. 834. Beautiful, guys. Congratulations. Now, this is how we interpret the data here, the table. Now, let's try to solve our questions. Let's try to solve the question. Let's go for the first one. A tourist is chosen at random, right? And that tourist will receive a promotional offer. I don't know what this is for, but cool. Cool for the guy, right? Now, guys, try to determine what age group is most likely the guy is going to belong to. So is this maybe the group that the guy is most likely to be from? Or maybe this group, or maybe this group? Which of these 4 group of ages is the most likely that the guy belongs to? Most likely. How do you do that, teacher? No, I don't know. Pretty simple, guys. Let's fill in. Let's expand our table. Here, that's the table, right? To expand the table, we're just gonna count all these numbers in here. Let's do the totals. All right, you guys can help me with these totals. These will be the totals. Totals, right? So how many people have between 18 and 30 years old? How many? And how many between 31 and 50 years old? How many, please? And how many between 51 and 17? How many older than 70? That one, that last one we have it, right? 110? The last one we have it, right? Mafe, 305. This one? Thank you, Mafe. All right, the next one is 521, 29, right? If I do the subtraction, right? If I do the subtraction, yeah, 521, 29, right? Okay, how about the last one? Or not the last one, the third one. Lily, 286. Is that correct? All right, thank you, Lily. Thank you, Mafe. Cool. So we have the totals. We have the totals now. So let's think about which of these ages is the most likely the guy is going to be from. Well, to be the most likely, you need to have the biggest amount of data, right? So the biggest amount of people. Which of these 4 ages has the biggest amount of people? The second one, right? 31 to 50 years old. Okay, so let's go back to our question. What age group is the tourist most likely to belong to? To the second one. The table shows the total number of tourists 31 to 50 years old is 529, and this is the most frequent age group. All right? Cool. Now, by the way, guys, look, the book is giving a really cool tip. You can apply technology to be able to manage tables a lot easier, right? If you just copy this information in an Excel page, in an Excel book, you can have these additions done immediately. You don't have to do this by yourself. Just write the code, right? And you have this by yourself without having to actually use the calculator. All right, cool. Let's go to the second one. Find the probability, that the tourist chosen belongs to the age group. What is the probability? Okay, as usual, probability is success over total, right? In this case, we have our success, 529. That is the success. Each and every one of these 529 people will be successful. But what is our total? Okay, the total will be the total of every single amount of people. Every single person in this vacation, or I don't know, every single tourist. So can you help me with this addition, please? 305 plus 529. Can you help me with this, please? 1,330. Beautiful. So that right there is our total. Again, so the probability will be success over total. The total is 1,330. And the success, again, look at the question. Find the probability that the tourist chosen belongs to this age group. What group? Well, the one that we just found, this one, 31 to 50. So that is our success, 521 and 39. There. Is the question saying something more? Expressing your answer as a decimal. Okay, we have to write down this as a decimal. Can you help me with, please, guys? Round this to what? Round this to 2 decimal, please. Thank you, Mafe. Mafe, are you sure you round, or did you just count? Did you just cut the decimals? 0. What? 0.4? Ah, okay, you didn't round. All right, thank you, Mafe. All right. Don't forget to round. Don't just count. Don't just cut the decimals. No. Round, please. Round the answers. All right, 0.4. There it is. There is a 40% that the guy is chosen from there. All right. Cool. Cool. All right, last question. In July of 2019, look at this, man, 16,000 tourists are predicted to visit the town. If the town's hotels have capacity for 5,000 only, we need to predict if the town has enough hotel capacity to meet the demand. So how can we predict this? Take a look at this. Bueno, pasa un momentico al español. A la primera vista uno dice, ok, pues vienen 16,000 y solo hay espacio para 5,000. Pues no hay espacio. Ok, pues eso estaría mal. Porque mira que estos 5,000 son de los hoteles. O sea, esta columna de acá, hoteles. Este valor y este y este y este. No es todos los valores, no son todos. No, solo para los hoteles. Entonces vamos a encontrar la probabilidad de que una persona se vaya al hotel y luego encontramos el expected value de los 16,000 para saber de estos 16,000 cuántos esperamos que vayan a hoteles. Si ese valor es menor que 5,000, estamos bien. Si ese valor es mayor que 5,000, pues no hay cama. Se esperan más personas de las que hay cama. Okay. How do we find that value? Simple. Can you help me with this total, please? Ay. Anybody in the chat, please? Mafe did it already. Thank you, Mafe. 370. Thank you, Mafe. So this is the amount of people that in this example, right, we have for hotels. 67 plus 107 plus 87 plus 109. So what is the probability that someone stays at a hotel? What is that probability? Well, success over total, 370. That is the success. Those are the ones from the hotel over the total, 1,330. Can you help me with this in decimal, please? Anybody? La la la. Anybody, please? 0.3? All right, 0.3 to one decimal, right? Honestly, I like two decimals, so let's do 0.27. But again, is this round or did you just cut the decimals? You need to round, please. Round. 0.27 or 0.28? Which one? 0.28. Look at that, guys. Man, I had to. Les voy a quitar esas mañas, muchachos. Algún día les voy a quitar esas mañas. Poniéndoles notas negativas o algo así. Redondeen, no, no solo corten el poco de decimales. No, 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 no. Hay que redondear. Ok, 0.28. Beautiful. 0.28. So this is the probability that one person stays at a hotel, right? So what is the expected value then? We are expecting 16,000 people. How many of these 16,000 do we expect to stay at a hotel? Well, remember the expected value formula. For the expected value, let me write it here. Expected value. The expected value will be the repetitions. So we have 16,000 times the probability. So 0.28. Right? How much is the expected value then? How much do we expect to stay at a hotel? In a calculator, please, somebody. How many? Maybe a third part of this? 5. I don't know, man. I think we don't have enough space. I think we don't have enough space. Anybody, guys?
Yes.
Thank you. How many? How much? Oh, look at that. 4,480. All right. So this is the expected value. We expect 4,480 people to stay at a hotel. This is what we expect. So do we have enough capacity or not? Well, the capacity is for 5,000 people. And we are expecting 4,480. So I think we have enough space, right? Congratulations. Let's take a look at the answer. All right, look at that. 4,451. This happened because we round, right? We round the decimal. In the book, the person, the one that's doing the example, that guy didn't round. The guy just used the fractionary, right? So I think this is one. This is a better answer than the one that we did. This is a better answer because when you round, you have mistakes, right? So when we round, we have a different answer. Right? Look at that. So there is sufficient capacity. We have enough space. Beautiful, guys. All right. We only have 4 minutes, 3 minutes. So I don't think we're going to be able to do these exercises. But guess what? If you want to practice for the quiz, practice with this. And there are a lot more in here. A lot more. Look at that. A lot more. All right. If you want to practice for the quiz, practice on this. All right. You know what? Let's use the time to try to finish at least one of these. For example, the question A. Just for example, one of these. All right. A survey was carried out in a small city on one Saturday afternoon. Now, shoppers were asked about how they traveled that day. And here are the results. Now, one shopper was randomly selected. Find the probability that this shopper traveled by car. Right, so these are the data for car. 40, and 13. What is the probability then? All right, the probability is the success over the totals. So we need to add 40 and 33 because those are the success for cars, right? So the success in our case is 77. Are you guys following me here or not? Beautiful.
Yes.
Thank you, Paul. So the success will be 40 plus 33, 77, right? Now, which is the total? The total is the amount of people in that center street. I don't know what this is. So what is the amount of people? Well, this plus this plus this plus this plus this plus this. Can anybody do it, please? How many people do we have? Anybody? It's the total, right? And the amount of people, so at the end, the big total here should be 239. Thank you, Mafe. 239. So what is the probability that one of these persons, one of these people, traveled by a car? The probability is pretty simple. The success, the car, over the total, 239. Can you change this to a decimal, please? Anybody?
Profe,
Yes.
a mí me dio 243.
It is 73 and 73 here. How much? 241?
Ah, no.
No? Okay.
No, ya.
Okay. Cool. So how many? What is the difference? What is the division here, please? Anybody? We can leave this as lead, right? This is a good answer. We can leave it like that if you want to. But I want to leave it as a fraction.
0,30.
0.31 maybe, if you round.
Sí, 31.
All right. Do not forget to round, please. Round,
Sí,
right?
es que el faro.
31. Beautiful. That is the first question. Beautiful. The probability. Cool. We could continue with this, but it is now 12:30, and I don't know about you guys, but I'm feeling hungry. So let's finish the class here.